So let's do another couple of examples of these polynomial inequalities. So let's take a look at this one here. I'm looking at 2x squared minus x greater than 1. Bring everything over to the left-hand side so that I can compare to 0. So 2x squared minus x minus 1 greater than 0. I'll factor this. Again, I'm going to do it by my normal trial and error. I'm going to say 2x, I'm going to say x, and I'm going to try 1 and 1. So that would give me 2x from the outers and 1x from the inners, and that could give me a negative x. The negative sign there tells me that I want different signs. I want more negatives so that I end up with negative x. All right. So I want the negative coming from the part that's going to give me negative 2x and the positive from the other part. So I get 2x plus 1 times x minus 1 greater than 0. And again, solving this as if I would for an equation, I'm going to find my zeros when we get zeros from each of these terms. So when I look at the 2x plus 1, that would be 0 when x is negative 1/2. If you don't see that, just set 2x plus 1 equal to 0 and solve it. For x minus 1, that's 0 when x equals 1. So I have my two zeros there, and they're going to go on the number line now. So I'm going to put the number line over here for some space. All right, so I need to put negative 1/2 and 1 on my number line. And that's where I'm going to break the number line. All right, and so I just need some numbers in each of these regions here. So I could use 0 in between negative 1/2 and 1. I could use negative 1 on the other side of negative 1/2, and I could use 2 on the other side of 1. All right, so remember, I just need any number that's in that interval to use as a test point. Okay, so again, I'm going to take that test point. So if we go over here into the negative region, I'm going to take negative 1. I'm going to go back to where I have it nicely factored. And I'm going to be plugging negative 1 into those terms to see what I get. So if I plug negative 1 into 2x plus 1, that would be negative 2 plus 1. That's going to give me a negative value. If I plug negative 1 into x minus 1, that's going to give me negative 1 minus 1. So that's going to give me a negative. Overall, I'll get a positive because I'll be multiplying two negatives. If I plug 0 in, that will give me 1 from 2x plus 1, so that's a positive. And that would give me 0 minus 1 would be a negative. And so I get a negative overall. Finally, if I plug in 2, I'm going to get 2 into 2x plus 1 is going to give me a positive. And 2 into 2 minus 1 is going to give me a positive. So I get a positive overall. So now I know what it's doing in each region. So I can go ahead and go back and see, what did I want? Okay. I wanted greater than 0. That would mean positive. So here's one region where it's always positive. Here's another region where it's always positive. Now this time, because I don't have an or equals to, I don't want to include the breakpoints, because those are when the left-hand side is equal to 0. So when I go and do my solution now, in inequalities, now you see I have two separated regions on the graph, so I'm not going to be able to put these together. So I'm going to have to do them separately. So the region here on the left is everything below negative 1/2. So that's x less than negative 1/2. So that's part of my inequality solution. So when else would it work? Or I could have x greater than 1. That's what we're getting over here, is everything greater than 1. In interval notation, so x less than negative 1/2 would be negative infinity to negative 1/2 open. And then I'm over here, x greater than 1 would be 1 to infinity open. And these two intervals together make the entire interval solution. Graph-wise, get my number line. All right, so let me put negative 1/2 there. Let's put 0. Let's put 1, and that's good enough. Open at negative 1/2, and everything behind going to negative infinity. And then open at 1, everything ahead going to positive infinity. Again, or if you like, parenthesis back, parenthesis forward. And there's our solution. Okay. Let's go to the next one here. Now this one is not a quadratic anymore, because if I were to multiply out the left-hand side there, I would actually get, since I'm multiplying an x times an x squared times another x, I would get x to the 4th. But I can solve this in the same way as I did with the quadratics here. So this is a more general polynomial inequality. And it's actually, much of the work is done for me already. Everything is already on the left-hand side, and it's actually even factored. So it's already set up that I'm comparing to 0, which is good. So I'm basically skipping ahead and saying, what are my zeros? Well, my zeros are just when each of these terms is 0. So x equals 0, x equals 1, x equals 3. So that's already done for me. So I know my zeros. Those would be the solutions to the equation. But now, since it's the inequality, I'm going to go ahead and make my number line. Oops. Let's imagine that's a straight line. And I'm going to put 0, 1, and 3 in there. Okay. And again, it doesn't matter if it's spaced entirely correctly. We're just trying to get an idea of where these numbers are. So that's where I'm going to break the number line. And then I'm going to go in and get some test points. And so let me have a negative 1 over there, 1/2 in there, 2 in there, and 4 over there. Okay, so now I have 4 different regions, and I'm going to have to take each one of those test points and put them in. All right, so below here is where I'm going to show what the signs are of each of the terms, going back to x times x minus 1 squared times x minus 3. So if I do that, and I'm using the value negative 1 here, when I put negative 1 into x, I get a negative. When I put negative 1 into x minus 1 squared, well, I actually don't have to do any calculations. It's squared there, so it's always going to give me positive. And negative 1 into x minus 3 is going to give me a negative. So overall, if I multiply a negative times a positive times a negative, I'm going to get positive overall. If I put 1/2 in, I'm going to get positive, putting in for x. The middle term is always going to be positive, and 1/2 minus 3 is going to be negative, so I'll get a negative in there. If I put in 2 now, I'm going to get a positive. I'm going to get a positive from the middle term, and I'm going to get a negative from the middle term, and that's going to give me a negative overall. If I put in 4, that's going to give me positive, positive, positive. And I'll get a positive when I multiply those 3 numbers together. Okay, so what did I want? Let's go back. And what we were asking for less than 0. So all we want is when we have negative. So here's one place we have negative, here's another place we have a negative. So those 2 intervals, again, it's not an or equals to, so we're not going to take any of the breakpoints. So our solution, inequality-wise, now these are actually 2 broken regions because there's the 1 in between here is not in either of these regions. So I actually have to write this as this region here would be 0 less than x less than 1. So, or I can be in this other region here, which would be 1 less than x less than 3. Interval-wise, that would be 0, 1, not including either endpoint, union 1, 3. Again, not including both open, not including either endpoint. And graph-wise, well, this graph is going to look a little strange because I'm going to have, so let me put 0, 1, 2, 3. I'm going to have open at 0 and open at 1, take everything in between it. And then from 1 to 3, I'm still open at 1, and then I'm open at 3 and take everything in between it. Okay, so you have the open interval from 0 to 3, but also not including 1 in the middle there. If you use parenthesis notation, you'd have to put some back to back there and have something like that. So those were some polynomial inequalities.